The next one is scenario 2 is slightly different. It is a categorical or a discrete variable. Here, number of times 30 to 59 days past due but not worse. What are the issues here? Number of time 32, like let me say 30 DPD, 30 DPD or 30 days late frequency. Okay. It can take value 0, it can take value 1, 2, 3, 4, it can take 5, it can take 6, 7 and so on. It can take until 24, isn't it? It can take all these values. However, in our case, it took the value like 5, 6, 7 and so on 24. It took the value 96 and 98. That is the problem that we are facing. It should not have taken 96 and 98, but it is taking here. Let me write down cleanly here. So 30 DPD, number of times you are late in 24 months. You have never been late once, twice, thrice, 4, 5, 6 times and so on. 24 is okay, but 96 happened, 98 happened. Now that is wrong, isn't it? How do you deal with this? That's a question. This is a numerical variable, even if it is non-numerical variable, even if it is a categorical variable, something like customer, country A, B, C, D, E, these are the countries and so on. There is some default country or some country missing. A country NA is coming. Okay. Now the country value should be either A or B or C or D or E. If it is missing or NA, what will you do here? Here in this case, or here also there are some default values that are kept. Default value is, let's say, NA country, NA1, NA2. What will you do here? You cannot find the average country here. Average country will be A point B or C point D. It will not be like that. You cannot simply find the average of these values and then simply find that like 1.5 or 2.5. You cannot do that. So Pranaya has a very simple answer. Avoid that. छोड़ दो भाई, मतलब इतना क्यों परेशान हो रहे हो? बहुत ही easy answer. Very good. Avoid that. अरे class को ही avoid कर दो फिर. Avoiding is not the solution. That's what not we are paid for. Avoiding तो कोई भी कर सकता है ना. What do you say, Pranaya? We have to. Yeah, it depends on the percentage. Yeah, if you say that if it is 0.01%, do not bang your head on this. I agree. I agree to your point if it is negligible. But sometimes these are significant. Maybe these will change your analysis upside down. What can you do is the question. In this case, what we do in business is there is a technique called impute them based on a related variable. Impute them based on a related variable. Okay. What do you mean by impute them based on a related variable? Let me give you an example here. Can you tell me, looking at this data, you have x1 given here, x2 given here. If I find the average of x2, that will come to around 0. Can I put 0 and 0 here? Or can you give me a better imputed value? Tell me. Can you give me a better imputation value, which is kind of logical, meaningful, and I should be convinced that you had to fill something here, fill something here. Can you tell me that? In the chat window, tell me what is best value that I can impute here, what is the best value that I can impute here. And it should be very logical. Can I say I'll put -3 here, I'll put -6 here, and I'll be very happy with that? If yes, why? When x is -4, x1 is -4, what is x2? When x1 is 2, what is x2? When x1 is -6, what is x2? When x1 is 8, what is x2? When x1 is -1, what is x2? Look at this carefully, all of you. Is it justified if I keep 3 here, if I keep -3 here, -6 here? Tell me. Is it justified? Or do you think that is not a right way to do it? Is it making logical sense to you? Tell me. How did we do it? We found a relation between these two variables. Based on this variable, like there are some places where it is available, this one is not available. Based on this variable's help, we have filled it. Tell me another example. Tell me, what should I fill here? What should I fill here? What should I fill here and what should I fill here? In the first case, what is the number that I can fill? In the first case, you can fill 1. In the second case, you can fill 0. Yeah. These are just simple examples. So as I am writing this, one of the questions that I received is, what if you have millions and millions of rows? Will you go like this, or is there any better method? That is what we are going to see right now. What if there are so many rows? Which method are you going to follow? So especially when there are categorical variables, based on the related variables, we are going to fill it. One of the most important variable in this, let me show you the data dictionary, and based on your experience, tell me one critical variable. There is one variable that is considered as the most critical variable out of this list. Can somebody tell me that? What is that one critical variable that is the most critical out of all this? It is like the heart of this data set. Whether I miss any other variables or not, it doesn't matter. But if I don't
depth ratio.
If I don't have that variable, then I am gone. I can't do anything. What is that variable? Think about it in a credit risk scenario. What is that variable? That is one important variable. If you don't have it, then you are doomed. You cannot proceed further. Maybe if I don't have some particular variable, I can still proceed. If some of the variables are missing also, I can still proceed. I can build the model. But there is one variable, without that I can't even proceed. That variable is serious delinquency. Previously, whether you are a good customer or a bad customer, the target variable, this is what you are predicting. If you don't have this, you have all this information, you will not get to know who finally led to risk, who did not lead to risk. Let us suppose if you don't have monthly income, still somewhere from debt ratio, age, or somewhere this information is hidden, you can grasp it. Even if you don't have age, or even if you have debt ratio, if you are missing one or two variables here, still you can build a model. But if you don't know the target variable, you can't even build a model we haven't discussed. But still, on the overall level, if a person was good or bad, that means 0 or 1, seriously delinquency, yes or no. Without that, it will be difficult. Okay. So this is one important variable. Usually this is known as bad indicator. Customer is bad or good. In fact, in all those credit risk teams, always you will hear this term bad, bad, bad all the time. Everybody will be talking what is a bad definition, what is a bad indicator, what is a bad rate. Like that, you will always hear this term bad, bad, bad and all that. Okay. One of the critical variable. So other variables treatment, when you're doing, if you want to take any help of any other variable, one critical variable is serious delinquency in last 2 years, or the target variable, whichever is the target variable. So here in my case, I have an issue. I'm going to resolve it using that target variable. Very smartly we are going to use it and then check whether that will be helpful or not. Okay. Let's go back here. What we are going to create is, we are going to create first a cross tab between 30 DPD variable and the target variable, which is serious delinquency, which takes two values, zeros and ones. We're going to create a cross tab. Look at this carefully, all of you. The first variable is serious delinquency, the one that is in the columns. The other one is 30 DPD, that is when it is in the rows. So how many times the 30 DPD was 0, that will be the sum here. But out of them, how many are zeros? So serious delinquency has zeros and ones. 0 means, let's say, good. 1 means seriously delinquent, that means he is bad. Okay. Out of 30 DPD, when it was 0, how many are zeros, how many are ones, how many percentage of time? Let's say 95% of the times good only, 5% of the times bad. From where I'll get this information? From the data only. So I'll go to the data, I'll create a cross tab. In fact, first I'll get the frequencies. Maybe there are 950 or 9,500 customers here. There are only 500 customers here. Okay. Then I will get I'll convert into percentage. 95% are here and then 5% are here. Okay. What about this one? Again, I will find out the percentages. When the 30 DPD is 1, out of them, how many are zeros, how many are ones? In fact, this is known as, these are good. This is good rate. This is bad rate. What is a bad rate in bucket 0? What is a bad rate in bucket 1? Let's say bad rate in bucket 1 is 10%. What is a bad rate in bucket 2? Let's say 82%, 18%. What is a bad rate in bucket 3? Like that, maybe bad rate in bucket 4. Let's say this is 1 bad rate, corresponding bad rate in bucket 2. Bucket 3 bad rate is, let's say, let me say 75% and then 25%. Bucket 4 bad rate 70%, 30%. Like that, you will find the bad rate in every bucket. You will also find the frequency of 96, frequency of 98. You can also find the bad rate in each of these buckets because you have the data with you. Maybe 96 bad rate is coming as 90% and 10%, and 98 is coming as 70% and 30%. For now, I will even ignore 96 because it has only fewer records. Let us focus on 98. Okay, 98 bad rate also, you got it. How will you get the bad rate? You find out how many records are there. Okay, 700 are falling here, 300 are falling here. So 70% are good customers, 30% are bad customers. Now, my question to you, all of you be ready with the answer. My question to you is, I know 98 is wrong. I know 98 should be replaced with either 0 or 1 or 2 or 3 or any value between 0 to 24. Can you tell me the best replacement for 98? Shall I replace it with 0 or 1 or 2 or 3 or 4? What is the best replacement for 98? Why? Why? What is the best replacement? First question. Second question is why, if you're choosing a replacement. Perfect. When bad rate, if you see, is something which is a wrong value, bad rate in that is 30%. I will go to the permissible values. I will check the bad rate. 30% bad rate in bucket 4. So if this is wrong, maybe these values are very similar to bucket 4. It is very much justified. Instead of 98, I can keep 4 here. Totally on the bad rate, similar distribution, that is right. Bad rate, bad is distributed similarly in a bucket that is permissible. Here it is not permissible, 98 is not permissible. Then I would say maybe these guys are falling from here. It is justified if I replace that with this one. Are you with me? Same way, even categorical country A, B, C, D, E, and then there is a country that is missing. You don't want to keep this NA. You want to replace it with either A or B or C or D or E. Which one will you replace? You look at a bad rate. And then whichever country is very near, need not be exactly same, very near bad rate as this one. Let's say C has a very near bad rate. I would say that missing can be C. This particular trick will give you very good results rather than simply replacing with either 0 or 24 minimum or maximum and all that. Anyway, mean cannot be done here because these are all categorical. We compare to the bad rate. Are you with me, all of you? So when you are in a situation like this, where you are dealing with discrete variables, you need to compare it with the bad rate. Good distribution, bad distribution, similar distribution, you have to mix it. Let me show you in our particular problem. This is just an example that I have shown, but in our particular problem, we have to create that frequency table. This is the original frequency table. You have zeros here, ones here, twos here, threes here. All of them are fine. 96 is not fine. 98 is also not fine. Now I'm going to create a cross tab. This one is overall issues, how much of the issues, very, very small data that is issues. I will try to see the cross tab. What is a cross tab? The same frequency here, that will be now cross tab or pivot table kind of scenario where 30 DPD versus 0, 1 serious delinquency. So these many records here will be now divided into zeros here, ones here. These many zeros, these many ones, these many zeros, these many ones. But looking at the plain numbers will not help us. We need to look at the percentages as well. Now these are the percentages. Cross table with the percentages. 96% are good. Bad rate is 4%. Bad rate is 15%. Bad rate is 27%. Bad rate is 35%. Finally, I'll come to this 98, which has a bad rate of 54%. Now, if you have understood this methodology correctly, then in this particular problem, can you do this? Can you run this and tell me what is the bad rate in our problem? What should I replace 98 with? Can you find that bucket? Is it bucket 0 or 1 or 2 or and so on or 24? Can you tell me that? Okay. Now, find out which bucket should I replace this 96 or 98 with. As of now, I'm not talking about 96. Let us keep it aside. It has too fewer records. So then looking at these percentages, bad rates may not make sense. I'll tell you a different method for it. Look at 98, which is having good chunk of records. Tell me for 98, what I should replace, which bucket?
Bucket 6.
Yeah, bucket 6. Let me check that. Let me check. 54 is the bad rate. If I check 54 bad rate, the nearest one is 53 bad rate, bucket 6. That's right. Now look at this 96. When it is 96, then the bad rate is 80%. But I will not consider this very seriously because there are only 5 records here. Out of 5 records, 4 are, one remaining 1 is here. So what I'll do is in real business, if there are only 5 records, we don't take that seriously. Whatever we do with 98, we simply do it with 96. Are you with me? This is not given extra preference. You can give that also. You can check out, maybe you can replace that with a 10 and all that. But in reality, if you ask me, if there are some default values like this, if one of them is driving most of the population, whatever you do with 98, you simply do it with 96. So here is the final treatment that you're doing. So what we are doing here is 13 also, in fact, 13 is also not encouraged. So 13, your 96, 98, all of them have been merged and replaced with 6. Here is the case. Look at this. Create a new variable, which will be cleaned version. Whenever this variable is more than 12, that means we are considering them as unaccepted values. All of them in one shot, replace them with 6. Now everything afterwards in this new variable, all these values are acceptable. You don't have 96 and 98. This simple technique will help you to remove the issues that are having with this default value. Sometimes instead of 98, you will have 998 or 4 times 9 or 5 times 9. Same technique can be used. Even if it is a categorical variable, sometimes you have country name or segment name or ABCD, all of those can be done using this method. Okay. Any questions on this?